The industry needs to be sure that we can safely change from high blends of biodiesel to lower blends without causing issues with the appliance or creating dangerous levels of carbon monoxide. If any of these situations could occur, changing from high blends to lower ones would require that a service technician adjust the burner immediately after each delivery. We also have the same concerns about switching from low blends to high blends. To address these questions, extensive testing was performed at NORA's research lab. All testing involved properly adjusting burners with a combustion analyzer for a certain biodiesel blend and then switching to a different blend without making any adjustments. Running the unit at a steady state for 5 minutes and then recording the results. Throughout the testing, carbon monoxide readings were under 10 parts per million and were considered to be near zero. The first set of tests were performed on a Carlin EZ1 burner. The burner was adjusted for and operated with B100. The smoke reading was 0 and the CO2 was measured at 11.3%. Carbon monoxide in the flue gas was measured as near zero. The fuel was then switched to number 2 oil, or B0. The smoke reading remained at 0 and the CO2 went up to 11.7%. Carbon monoxide remained at near zero. The next step in the Carlin EZ1 testing started with adjusting the burner using B20, then switching to B0, and then switching again to B100. Combustion testing showed that the carbon dioxide reading went up 0.1% when the change was made from B20 to B0, and it went down 0.3% when the change was then made to B100. Smoke remained at 0, and carbon monoxide remained at near zero throughout the test. The next set of tests were performed on a Beckett AFG burner using the same parameters as those used in the testing of the Carlin EZ1. Once again, the burner was adjusted using a combustion analyzer for a certain biodiesel blend and switched to different blends without making any adjustments. For each blend, the burner was operated at a steady state for 5 minutes, and the test results were recorded. To determine if decreasing blends might be problematic, the burner was adjusted for B100, then the fuel switched to B50 and switched again to B0. The CO2 difference between the three fuels was 0.2%. Once again, the smoke remained at 0 and the carbon monoxide remained at near 0 for all three fuels. To determine if increasing blends might be problematic, the burner was adjusted for B0, and then the fuel was switched to B50 and switched again to B100. The CO2 difference between the three fuels was 0.2%. Smoke readings remained at 0 and the carbon monoxide remained at near 0 for all three fuels. The preliminary results gained from testing with the Carlin EZ1 and the Beckett AFG are that as long as the burner is properly tuned to begin with, there are no carbon monoxide or smoke issues involved with increasing or decreasing biodiesel blends, and that the CO2 differences are minimal. The next step in this first round of testing was to determine if CAD cell resistance readings were so much higher with biodiesel blends that burners would shut down on safety, causing nuisance lockouts even when the burner was operating properly. The Beckett Genesis display tool was used to measure CAD cell resistance for both burners in this test. The tests were carried out in a manner similar to the testing on combustion. The burners were adjusted using testing equipment and run at steady state for 5 minutes before the readings were recorded. The fuels were then switched, no burner adjustments were made, and the process was repeated. Carbon monoxide levels of 10 ppm or less were considered to be near zero. For the Carlin EZ1 burner, the CAD cell reading was B0 at 260 ohms. The reading went up to 620 ohms when the fuel was switched to B100. Next, the Beckett AFG burner was adjusted for B0 and then switched from B50 then to B100. And the readings were 260 ohms at B0, 340 ohms at B50, and 740 ohms at B100. While the readings more than doubled when the level of biodiesel was increased from B0 to B100, it was significantly less than the level that would cause the burner to shut off on safety. The Honeywell R8184 control lists 1600 ohms as the lockout threshold. The B100 readings of the Carlin EZ1 and the Beckett AFG are less than half of that. The Beckett Genesis control locks out at 4000 plus ohms. And the Carlin Pro X lockout threshold can be selected to either 3300 or 5300 ohms. Clearly, using a higher level of biodiesel should not cause properly operating burners of these two types to experience nuisance lockouts. The first round of testing demonstrated that there should be no combustion or flame sensing concerns about the burners that were tested. However, there are many other oil burners in the field, and NORA decided that more testing was needed before an industry-wide move to higher blends is advisable. These tests included the Beckett NX burner, the Riello F3, and an obsolete 1725 RPM non-flame retention Mohawk burner. The fuels tested for each were B0, B20, B50, and B100. Each burner was first adjusted for B0, then blends were increased to B20, B50, and B100 with no burner adjustments. Then each burner was adjusted for B100, and the blends were decreased to B50, B20, and B0 with no burner adjustments. The parameters that were measured include carbon dioxide, carbon monoxide, CAD cell readings, and flue gas temperature. Combustion efficiency calculations for biodiesel blends are not currently programmed into most combustion analyzers. The readings shown were calculated by NORA's Research Lab Director, Dr. Tom Butcher. It is important to note that many of the differences reported are within fractions of a percent of carbon dioxide or single digits of carbon monoxide. These variations are within the combustion testing equipment's margin of error. Here are the results with the Beckett NX when the biodiesel blend was increased from B0 to B100. The carbon dioxide readings decreased 0.1%, and this is within the margin of error. The carbon monoxide decreased 1.1 part per million. The CAD cell readings increased by 736 ohms. The flue gas temperature decreased by 5 degrees, and the combustion efficiency decreased by approximately 0.2%. Here are the results for the Beckett NX when decreasing blends of biodiesel were used, and smoke remained at 0 for all fuels once again. The CO2 reading stayed the same at 12.1%. For the carbon monoxide, there was an increase of 0.1 part per million. CAD cell readings decreased by 540 ohms. Flue gas temperatures decreased by 9 degrees. And the combustion efficiency increased by approximately 0.5%. Testing the Riello F3 and increasing the biodiesel levels from B0 to B100 gave the following results. And again, smoke remained at 0 for all fuels. The CO2 reading, there was a decrease of 0.2% from B0 to B50. And for carbon monoxide, there was a decrease of 0.2 parts per million. CAD cell readings increased by 25 ohms. Because of the difference in design of the flame sensing components of Riello burners, CAD cell readings were measured by installing a standard CAD cell assembly into the burner's air tube. Flue gas temperatures decreased by 1 degree, and combustion efficiency decreased by approximately 0.2%, again for B50. Increasing to blends higher than B50 were problematic. NORA is currently having discussions with Riello to resolve the situation. The results when decreasing biodiesel blends with the Riello F3 were as follows, and smoke remained at 0 for all fuels. The carbon dioxide reading increased by 0.9% when decreasing from B100 to B0. Carbon monoxide stayed the same. CAD cell readings decreased by 1,374 ohms. The flue gas temperatures decreased by 4 degrees, and combustion efficiency increased by approximately 0.8%. Here are the results with the increasing blend levels with the Mohawk burner And remember, smoke remained at number 1 for all fuels. The carbon dioxide readings, well, there was an increase of 0.1% from B0 to B100. Carbon monoxide had a decrease of 5 parts per million. CAD cell readings increased by 407 ohms. Since CAD cell technology was not available when the Mohawk burners were manufactured, CAD cell readings were measured by installing a standard CAD cell assembly onto the burner firing assembly. The flue gas temperature decreased by 2 degrees, and combustion efficiency decreased by approximately 0.4%. Now let's take a look at what happens when the decreasing blends of biodiesel were used in the Mohawk burner. And once again, smoke remained at a 1 across all the fuels. The CO2 reading increased by 0.1%. The carbon monoxide had a decrease of 4 parts per million. The CAD cell reading decreased by 1,628 ohms. The flue gas temperature increased by 6 degrees, and the combustion efficiency stayed the same. Testing the additional burners reinforced the observations from the initial testings in the lab, and backed up by tens of thousands of oil heat systems operating on B20 for 12 years or more. There is no efficiency, carbon monoxide, smoke, or nuisance lockout issues involved with increasing or decreasing biodiesel blends to B20.